So if we look first at the back of the electron configuration handout, we're going to be looking at the orbital diagrams for the atoms. This means that we're going to be looking at the specific assignment of the electrons to orbitals for the atoms. So hydrogen. As a neutral atom, hydrogen has one electron. Its atomic number is 1. So that when we place hydrogen's electron into an orbital, we need to place it into the lowest energy orbital that we have. And so for any element, its first electron is going to be placed into that 1s orbital. For hydrogen, that happens to be its highest energy electron and its only electron. But for any element that follows hydrogen, electron number 1 will also go into that 1s orbital. Helium, its atomic number is 2. As I place the electrons into orbitals for helium, I'm going to place electron number 1 into the 1s orbital, just as I did for hydrogen. Electron number 2 then also goes into the 1s orbital, completing the 1s orbital. It is now filled. The first shell of electrons is also filled for helium. As I go to lithium, lithium has an atomic number of 3. That means I need to place 3 electrons into the lowest energy orbitals. Electrons 1 and 2 are going to go into the 1s orbital, just as they did for hydrogen and helium. Electron number 3 is then going to go into the next lowest energy orbital, and that's going to be the 2s. So for lithium, its 3 electrons are placed in the 1s and the 2s orbitals. For beryllium, we have an atomic number of 4. We're going to use what we already know about the placement of the first 3 electrons based on what we did for hydrogen, helium, and lithium as we move on to beryllium. So that as I move from lithium to beryllium, I'm adding 1 electron into the structure. For beryllium, hydrogen and helium told me where electrons 1 and 2 will go. Lithium told me where electron number 3 will go, and I know that the next electron is going to complete that 2s orbital, so that beryllium's 4 electrons sit in the 1s and the 2s orbitals. This completes the 2s orbital. That means that to place the next electron for the next atom, I need to access the next lowest energy orbital. That's going to be the 2p. So that for boron, I'm going to use what I learned about the placement of the first 4 electrons for hydrogen through beryllium in order to place boron's first 4 electrons. Then I'm going to use what I know about the energy of orbitals to place boron's electron number 5. So I'm going to go 1 and 2 into the 1s, 3 and 4 into the 2s, and electron number 5 goes into the 2p. Pause the video and see if you can complete the orbital diagram for the rest of the elements across the second period of the periodic table. Carbon has 6 electrons. 1 and 2 go into the 1s, 3 and 4 go into the 2s. Electron number 5 goes into the 2p, and remember that in accordance with Hund's rule, electron number 6 is going to go into a second 2p orbital, where it will have a parallel spin to the first electron that I placed into that 2p orbital. Both of these electrons may be spin up or spin down, but they must be parallel. As we move on to nitrogen, atomic number 7. Electrons 1 and 2 go into the 1s orbital, 3 and 4 go into the 2s. Electrons 5, 6, and 7 get spread across those degenerate 2p orbitals. For oxygen, I need to place 8 electrons. So I have electrons 1 and 2. I have electrons 3 and 4 in the 2s, and electrons 5, 6, and 7 spread across my degenerate 2p orbitals, but electron number 8 must now be paired. So electron number 8 will go there, and I'll have 2 electrons in that first 2p orbital, such that I have 2 unpaired electrons in my other 2p orbitals. For fluorine, I need to place 9 electrons. So I will place electron 1 and 2 into the 1s orbital. I will place electrons 3 and 4 into the 2s, electron 5, 6, and 7 across that 2p subshell. Electron number 8 was the first electron I paired up in the 2p subshell, and electron number 9 is my new electron for fluorine. For neon, I need to place 10 electrons. Neon falls at the end of the second period on the periodic table. For neon, electron number 1 and 2 gets placed into the 1s orbital, 3 and 4 go into the 2s, 5, 6, 7, 8, 9, and 10. So that neon is at the end of the second period corresponds to the place where all of the orbitals in the first two shells have been filled. Now as I go back and write an electron configuration is going to tell me the shell, the orbital, and the number of electrons that sit in that orbital. So for hydrogen, having one electron in the 1s orbital means that its electron configuration is going to be 1s1. For helium, its electron configuration tells me that I have two electrons that sit in that 1s orbital. So for helium, my electron configuration is 1s2. Helium is at the end of the first period on the periodic table, and it corresponds to the position where the first shell of electrons is now filled. For lithium, I have two electrons in a 1s orbital and one electron in a 2s orbital. So my electron configuration is going to be 1s2, 2s1. And if I were to add up my superscripts, the 2 plus the 1, it tells me that I've placed 3 electrons for lithium. Pause the video and write the electron configuration for the rest of the elements in the second period. So that as you've written all of the electron configurations for the elements in the second period. For beryllium, we have 4 electrons in our orbital diagram placed in the 1s and the 2s orbitals, so our electron configuration is 1s2, 2s2. For boron, we have 5 electrons placed in our orbitals, and our electron configuration is 1s2, 2s2, 2p1. For carbon, we have 6 electrons placed, and our electron configuration is 1s2, 2s2, 2p2. For nitrogen, we have 7 electrons placed, giving us an electron configuration of 1s2, 2s2, 2p3. For oxygen, we have 8 electrons, giving us an electron configuration of 1s2, 2s2, 2p4. For fluorine, we have 1s2, 2s2, 2p5, and for neon, we have 1s2, 2s2, 2p6 for our electron configuration. Don't forget that in every case, if you add up the superscripts, like here for neon, 2 plus 2 plus 6, that should give you exactly the number of electrons that you have placed. 2 plus 2 plus 6 gives us the 10 electrons that we have placed for neon. You should be able to write an electron configuration for all of the elements in the first 3 periods of the periodic table.